Okay guys, so we're finishing out section 11.6 and we're going to start on number 7. So I don't have common denominators. I want to look at my coefficients first. 10 and 4 both go into 20. X and x squared, remember I want to take the most x's, so I'm going to take x squared. Then I'm asking myself how my denominators changed. So how did I go from 10 to 20? I multiplied by 2. And how did I go from x to x squared? I multiplied by x. How did I go from 4 to 20? I multiplied by 5. And x squared to x squared, there wasn't a change there, so I don't need to do anything on top. Now I just need to clean this up and squish it together. So I would have 6x minus 5 all over 20x squared. Now my final step is to make sure that it's simplified, so I've got to factor first. 6x minus 5, 2 terms. I can't take anything out. It's not a difference of squares, so there's my final answer. Okay, that's number 7. Let's try that again. Let's look at number 17. Number 17 has 11 over 6x plus 2 over 13x. So again, obviously I don't have common denominators. I'm looking for what 6 and 13 both go into. 13 and 6 both go into 78. And then remember, I'm taking the most x's. Well, each of these just have x to the first, so I need an x to the first. Then I'm asking myself how my denominators changed. How did I go from 6 to 78? I multiplied by 13. How did I go from x to x? No change there, so I'm not going to do anything on the top. How did you go from 13 to 78? You multiplied by 6. And then from x to x, there is no change. So I'm not going to do anything in the top for that. Now I'm going to clean the numerators up, and I'm going to squish them together in one fraction. So 11 times 13 is 143. And 2 times 6 is 12. Now I could clean that up even further because I've got like terms here. 143 plus 12 is 155. Oops, sorry, no x's. Now I have one term over one term, so I don't need to worry about factoring, but I do need to see if I can simplify this. So if I put 155 over 78 into my calculator, hit my fraction button, no, that doesn't reduce. So there's my final answer. One term over one term. Remember, I didn't need to factor. I just needed to see if I could reduce my numbers. Okay, so that's number 17. So those examples were when I just had one term in the denominator. Now let's look at example 4. Example 4 has x plus 2 over x minus 1 minus 12 over x plus 6. Now remember, your very first step when you're supposed to be getting a common denominator is that you're supposed to factor the denominators. We didn't have to on those other ones because there was just one term. Okay, since there's 2 terms here, I need to see if I can factor. I can't take anything out. It's not a difference of squares. So I think of him as a set. Over here, I can't take anything out, and it's not a difference of squares. So I think of him as a set. Now, when I go to find my common denominators, it says Take the common denominator for the coefficient. Well, I don't have any numbers out front here, so I don't need to worry about that. The next part says take the most variable coefficients. Well, I don't have any x's out here, so I don't have to worry about that. Then it says take the most of each set, meaning I have an x minus 1 and I have an x plus 6. I have to take both of them. Now I have to decide how this changed. How did I go from x minus 1 to now x minus 1 times x plus 6? I multiplied it by x plus 6. And then on the other side, I had x plus 6. Now I have both of these sets. So that means I would have taken 12 times x minus 1. Okay, now I'm going to squish everything together. I'm going to squish everything together, and I'm going to use a method of foiling to clean this top piece up, okay? When you foil, you're working with first, outside, inside, last. So I'm going to take the first terms, x squared, the last terms, 6x, the inside terms, 2x, and the last terms, 12. Then I have this minus 12 that I need to distribute to that piece. So negative 12x plus 12. That's all over that denominator. I don't want to FOIL him out. I just want to keep him factored for. Now, I need to continue to clean this up. So I have an x squared. Looks like I have 8x minus 12 would be negative 4x. And then 12 plus 12 would be 24. Now that I've cleaned it up, I've squished it into one fraction, I have to make sure and see, can I factor this? Okay, 3 terms. I can't take anything out. Are the first and the third perfect squares? No. So now I need factors of x and factors of 24 that will give me negative 4. X and x. Remember, my factors of 24 are 1 and 24, 2 and 12, 3 and 4, and, oops, yeah. Not 3 and 4, 3 and 8, and 4 and 6. Now just glance at those factors, guys, because you know it's just working with x and x. It's not like he had a number out front either. I'm supposed to be getting to negative 4. Okay, well, 1 plus 24 is going to give me 25. 24 minus 1 is 23. That's not going to work. 2 plus 12 is 14. 12 minus 2 is 10. He's not going to work. 3 plus 8 is 11. 8 minus 3 is 5. He's not going to work. And 4 plus 6 is 10. 6 minus 4 is 2. He's not going to work. So there are no factors of 24 that are going to get me back to this negative 4 when I add or subtract them. That means this isn't factorable. And that's as far as I go. And remember, if he's not factorable, he's like a set. He can't be canceled with anybody. So that's my final answer. Okay, so going back through, we couldn't factor our denominators. So we think of them as sets. We have to have both of them. Then we created our new numerators by seeing how our denominators had changed. Then I cleaned up the tops by using a method called FOIL, multiplying the first, the outside, the inside, and the last, distributing that negative 12 so that I make sure I subtract. Then I cleaned this up by combining like terms. Tried to factor the top. I could not. That makes him a set. That means nothing can cancel. Okay, so let's try that on number 22. Number 22 gives me 2x over x minus 1 minus 7x over x plus 4. Okay, so obviously I don't have common denominators here, so I need to see if I can factor the denominators. 2 terms. I can't take anything out. This guy's not a square, so that's a set. 2 terms, can't take anything out, and it's not a difference of squares. That's a set. Now, when I go to find my common denominator, remember I need the common denominator from the numbers. Well, I don't have any numbers out front. I need the most x coefficients, meaning the x's out front. I don't have any x's out front. And then I need the most of each set, meaning I need an x minus 1, and I need an x plus 4. Now I'm looking to see how my denominators changed. How did I go from this to this? Well, I multiplied by an x plus 4, so I've got to take the top times x plus 4. Then how did I go from just x plus 4 to this? I multiplied by an x minus 1. Okay. Now I'm ready to clean up the tops and squish everything together. Now over here you have distributing, and over here you have distributing. So we don't have to worry about FOIL because we don't have a set times a set like we did in the last one. So you're going to distribute this 2x, and you're going to distribute this negative 7x. So that gives me 2x squared plus 8x minus 7x squared plus 7x. 2x squared plus 8x minus 7x squared plus 7x, since you have 2 negatives there. Still over that denominator. Okay. Now I'm ready to clean this up. If I clean up my x squareds, I have 2 and negative 7. That gives me negative 5. And if I clean up my x's, I have 8 and 7. That gives me 15. Which is x minus 1, x plus 4 in the bottom. Now remember, before we can simplify or anything like that, we have to factor. So if you look up at the top, 2 terms, can I take anything out? Well, I could take a 5. Oops, sorry, I forgot to put the x there. I could take a 5x out, but since it starts with a negative, I'm going to take a negative 5x out. So that's going to give me, oops, forgot I was taking a negative 5x. Okay, so x would be left here, and then minus 3. Bottom gets to stay the same. Now, granted I factored, but once you factor, you see that nothing can cancel here. My sets can't cancel, and there's no numbers or variables out front to cancel. So there's my final answer. Okay, that was number 22. Let's look at number 27. 27 gives me 2x plus 1 over 3x minus 1 minus x plus 4 over x minus 2. Obviously, I don't have the same denominators. Before I find a common denominator, I have to make sure they're factored. So 2 terms, can I take anything out? No. Is it a difference of squares? No. That's a set. Okay, second one, x minus 2, can't take anything out. Is it a difference of squares? No. That's a set. So now when I go to find my common denominator, I'm supposed to take the most of the coefficients, or I'm supposed to get a common denominator. Well, I don't have a coefficient out front. I'm supposed to take the most x's that are out front. I don't have any x's out front. And then I'm supposed to take the most sets. So I have 3x minus 1 and x minus 2. Now I have to look and see how my denominator has changed. How did I go from 3x minus 1 to this new denominator? I multiplied by x minus 2. How did I go from here to here? I have this 3x minus 1. Now we've got two sets times each other, so that's when I have to do FOIL here. So I'm going to take first 2x squared outside negative 4x inside x last negative 2. I'm running out of room, so I gotta scoot this over here. Okay, now this is a little trickier because you have minus in between here and you can't really distribute him before you FOIL. So I would just for right now say minus, and then now let's distribute this. Or sorry, now let's FOIL this. 3x squared outside gives me negative x. Inside gives me 12x. And last gives me negative 4. Still over that same denominator. Now we can clean this up further because if you have minus a quantity, you need to distribute that negative. So I have 2x squared. This first part is going to stay the same. And then I could distribute this so that it's negative 3x squared plus x minus 12x plus 4. Now I need to clean that up. Clean up your x squareds. 2 and negative 3 would be negative 1. Clean up your x's. Negative 4 plus 1 would be negative 3. Plus 1 more is negative 2. Plus negative 12 is negative 14. Then clean up your constants. Negative 2 plus 4 would be plus 2. Okay. Now when I go to look to see if I can factor this, guys, a big key to know if you can factor, this number here, this third number is smaller than 14, meaning factors of 2 are never going to give me a bigger number. So he can't be factored. 2 and 1 are my only factors here. There's no way that would add up to negative 14. So he's done. Okay. Now, I do want you to look. Just look at number 31. Number 31 there. I'll see if I can get it on my camera. It's a little bit blurry, but notice number 31 has 3 fractions, okay? Yeah, it has 3 fractions, but the process is still the same. Look at each one of those denominators. Can you factor them, okay? If you can factor them, then you need to, and then you can put them together to make a common denominator, and you'll have to be doing a common denominator for all 3. So it's going to be a pretty lengthy problem there. Okay? All right, do your best.